am the deputy director of the Virginia Tech National Security Institute. And this research is sponsored by Dr. Hobson, Sandra Hobson, who is the principal deputy for strategic initiatives, policy, and emerging technology within the director of operational test and evaluation. And so really looking at how test and evaluation can change the landscape when we think about these rapid digitally transformed processes is what we're thinking about under these tests. Okay, so why do we want to do this? I love this picture because it's like the epic OV1 of all time. It comes from the Department of the Navy. Actually, I'm sure all the other services have another epic OV1. But this is actually, you can't see it on the screen with the Zoom call panel. Maybe I can minimize this. But anyway, this is the Navy's 30-year R&D plan. And what you're seeing here is really kind of highlighted in the bullets at the side, this proliferation of platforms that have multiple sensors. They operate on kind of multiple planes of existence. They're undersea, they're on their surface, they're in space, they're on land, and they have all these different information streams that are connecting how they engage. And when we're talking about the integrated acquisition portfolio reviews, I think that's a kind of a building block to thinking about how do we optimize our performance of the entire fleet, not just any one service, but the joint fleet or the joint operations when we're operating in this kind of ubiquitous information present environment, but we also currently acquire systems as platforms. And a third element that I really like to highlight is in this picture, if you think about the bits and bytes flowing through all these streams, and if they're actually connecting and if they're being interpreted in the right way, that's a huge interoperability problem, but also that information is overwhelming for humans to actually operate in. So how do we think about how we use algorithms more effectively that put humans on the loop? And so this is, if this is where the Navy is going in 2045, the government is going to need a way to understand how when you introduce a new platform or a new capability, or you upload a new algorithm, or you provide a new communication mechanism in this environment, how does that change our operational performance and our warfighting capability? And that's a wicked hard problem. So to do some of that, I think what we're highlighting is that we need to think about test and evaluation differently. We heard in the opening panel that thinking about RDT&E versus O&M is kind of a defunct thing from industry, which I'm going to now say that in every panel session or session that I'm in. But that really the rapid change in our technologies that's often enabled by software and can continually evolve over the lifespan of an acquisition program. Everything is, programmable today, from our radars to our sensors to what we do with the information coming off of those different sensors. So that rapid change allows us to update our capabilities substantially without new investments in hardware, but also results in several challenges, including the interoperability challenge, but also the cyber threat challenge before we even start to think about, well, now we're going to incorporate machine learning and AI. And so I actually put this slide together back when I was working on the program that is showcased in the picture here on the right. This actually comes from a Defense Science Board report that was published in 2018 and what you're seeing is software lines of code in conventional fighters versus the F-35, which is what has the box drawn around it on the end. The blue coloring is code on the jet at this point in time, 2017. Current, and then the green is all the support infrastructure, the support software. So everything from maintenance to on the ground nav kind of elements to it. And so this is an explosion in the software lines of code, but also enables kind of new capability. And really kind of highlighting in this that software functionality is, built to change over time. But also our current processes in RDT&E don't support that kind of independent evaluation by the government when it does change over time. And, how much do we need to go back and look at if you change one line of code versus 20 lines of code versus you add a new capability altogether? We don't have really good answers from kind of the science of T&E to do that. And we don't necessarily use all the tools. And to that point, our current methods and test and evaluation all too often fail to incorporate relevant, credible sources of information. This could be things coming from model-based systems engineering models, digital representations of the system of all kinds, traditional kind of physics-based simulations. And then as we move towards incorporating machine learning and AI algorithms on actual platforms, prototype environments that allow us to do that before we actually load it onto the platform. And then all of this really doesn't, when we have defined kind of periods of test and evaluation, but we can upload software at any point in time, we're not adopting to the speed of the need and or the speed of the threat, both from a cybersecurity perspective or otherwise. Because, if we can reprogram our technologies, so can our adversaries. And so the goal of this task, which just kicked off really October 1, is to kind of think about how do we address all of these issues. And one of the themes that I'm going to hit in the session today is that data and models are universal translators of information. And when I say models, I mean models in the most general sense, and that a model might be, a model-based systems engineering model. It might be a statistical model. It might be an emulator. It might be a smoothing spline. Things that are interpretable that we can use to translate information across different levels of test and evaluation. And so here is my transformation roadmap. It kind of has like a crawl, walk, run feel to it. And that we need to think about kind of what we know how to do now and what there are tools that we understand how to use to kind of what needs to change as we start to think about digital engineering and model-based systems engineering and the integration of machine learning and artificial intelligence into our systems. And if we don't do any of that, we're never going to be ready for this joint mission environment that's captured in the Navy's 2045 plan. And so that's everything. We were having a discussion during the break in terms of looking at VV&A differently. So that accreditation timeline and department processes often requires a person to kind of accept the risk and say this is suitable. And that, again, it's a manual process that involves a document that requires a person to sign off and say, I'm willing to use this for this test. And so thinking about, can we do that differently? Can we inform VVUQ and understand the uncertainty in our models and what they're actually useful for? That lowers the barrier on the person that has to sign off on it. They don't have to say, this is the perfect model, or I am accepting no risk. We've documented the risk. We say, here's the uncertainty. And so that is an element that I'm talking about in kind of our second little hexagon there, as well as thinking about things like how do we integrate information from across all relevant sources of information. Mr. Chris Collins, who's the Executive Director of Developmental Tests and Assessments, has been talking a lot about the continuum of testing lately, which DOT&E wants to try and support. And so one of the ways that they are thinking about supporting that is how do we do integrated test and evaluation through what they are calling the Bayesian sequential testing system, but it's really just given what I know so far, what's my prior information, and that could come from any source of a model, it could come from prior testing. What does that tell me about where I should go test next? And how does that change my distribution, my posteriors of what I report, and doing that in an iterative, active learning style sense. And so these are things that kind of are things that we have current processes for, but we know how to do now. But providing that foundation and kind of best practices there will allow us to think very clearly about, okay, well, now we have digital engineering models, MBSE models. Should that inform my tested evaluation? And how do we build the right buy-in there? And so DOT&E has identified 5 different pillars. These are on their website in terms of what they are doing with their strategic initiatives. And so test the way we fight, think about how this operational environment comes into play and test accordingly, accelerate delivery of weapons that work, increase the survivability of DoD in contested environments, pioneer T&E of weapon systems built to change over time, and foster an agile and enduring T&E enterprise workforce. And so I put this slide up there just to say that this is kind of where they're going from a strategy perspective, and the AIRC is really supporting across the board, but we'll really deep dive into accelerate the delivery of weapons that work, and that we're helping them think about, for those of you that were in the last session, let's not reinvent the wheel. Let's take what Mark's really already discovered and develop that the enterprise level T&E data management solution for test and evaluation. So we'll have slightly different lenses. We talked earlier about, that might be performance data, and we're definitely not hosting it at Virginia Tech because of the sensitivities of that data. But take those best lessons and apply it there, as well as integrating kind of all sources of information to better inform testing across that continuum. And then we're also really emphasized in Pillar 4, the weapon systems that are built to change over time. They've really emphasized digital twins and AI-based systems, but all of those require kind of the defensible T&E methods to go along with it. And everything from how do you do that technically to how do you implement that in a way that works with an existing policy, or identifying, what policies might need to change to enable that. And so as opposed to read every word on this slide, I'll just kind of say that integrated test and evaluation has been a priority in the department for a really long time. I think the first memo was signed out somewhere in like the 2008 timeframe. And there's been a lot of progress in terms of the integrated test element of that, and that the services have started executing tests that are collaboratively planned and have uses for both developmental test objectives and operational test objectives. But one of the things we've really identified is that there is a massive shortfall, and then leveraging all that information in decision making, which is informed by evaluations at each point in time across the acquisition lifecycle. And of course, there are correlations in test events that happen over time. So if we're driving an Army vehicle on a track over and over again to assess its reliability, and then we put it in the hands of operational users and we test the reliability, those two results are going to be correlated. That's not like we took like a whole new vehicle, but they're not going to be the same. Because we did do fixes between the earlier testing and the later testing, and we did change the user of the system. We, maybe had a developer or an engineer driving it on the track, or maybe it was just autonomously, on the track running. And then we have a soldier and the operational tests, and we're doing it on a track versus we're doing it out at Yuma. And so there are things that are different, but there are also very strong correlations between them. Of course, when we think about models that are, physics-based or model-based systems engineering, they are not going to be a perfect representation of what happens when the real user uses it in the operational environment, but it will be correlated. There's high correlation, hopefully, if it's a good model. And coming back to the point that I was making earlier on, like understanding what the model is, what it's good for, what its uncertainties are, and what the risks are, inform us on how much correlation and how much risk we're willing to accept when we use that information to plan future tests. And so that's really the goal of this integrated test and evaluation line of effort. And we're going to be doing some retrospective studies, as well as some forward-looking ones where we play with digital models and digital twins. And again, here, I think, the math and the capability is perfect. Like, this is stuff we know how to do today. We just need to prove it a proof of concept and something that resonates in kind of real defense systems. So kind of things that, are maybe a little bit more forward leaning is, I don't know if someone's seen this happen. Jeff, you've probably seen it. You'll just tell me everyone knows how to do this. But how do you actually take an MBSE representation of a system and use it to plan a continuum of testing? That is something that I think is, it makes perfect sense logically. There are models that people are building that kind of have gotten to that point, but actually doing that. And so we're hitting this on multiple fronts where we have, many of you, I'm sure, have seen Mark Blackburn's Skyzer system. There's Peter Bueling has a Silverfish system. These are systems that we have within the AIRC network that have really high fidelity MBSE representations of the system. And so we're going to actually take those to the next level and inform that continuum of testing and show how that could be done. But also working with the department very closely to think about when an actual system has these, how would we inform testing different? And then really the opportunity that I see for test and evaluation here is those models don't come without cost, right? the program office, the program manager, the industry partner is going to have to pay for those. And that's on the far side of my screen here. That's a representation of a cyber resiliency based systems engineering model. And additionally, we have all sorts of other types of models. So then I'm an aerospace engineer first. So of course I've got the fluid flow over an airfoil as my favorite physics-based model, or could be data model as well, depending on whether you're taking a CFD or a data-driven approach to that. And so each of these models that we're building costs money. And there has to be a return on investment overall. We don't want to just spend more to get more, but not necessarily get the return on investment coming back into RDT&E dollars and OMM dollars. And if we're not going to carry those models through to O&M, we're not going to get the return on investment. And so the only place that I see the return on investment in real budget cycles is T&E. And so someone was asking me earlier, why is DOT&E on board with this model-based systems engineering plan and using MBSE for T&E? They see the same lever. It's the only lever that we have for transforming how we do acquisitions and encouraging model-based systems. And that might be I might be being overly broad, and you guys can tell me the other levels later. But when you think about where do you save cost in the, first part of the acquisition life cycle, if you're going to spend more on getting your MBSE and your physics-based models, it's in smarter, better informed testing. And so it's really targeted to say, here's what data, after I know all this stuff about my models, here's what I think, performance might look like. And the last one that I have on my screen here is kind of a statistical representation of data. And so how do we take all of that to get a more confident assessment than if we had just had the last chunk, the data piece, which is kind of the current state of the art practice. And test and evaluation is very data centric, with in some cases where we have really well proven out physics-based models, we incorporate those as well. So it's expanding that information portfolio.
Good question.
Yeah.
Modeling simulation, test evaluation is about reducing risk, and you're talking about getting more data.
Yeah.
Getting better insights, hopefully earlier on, but the idea though is that you're reducing risk is better information.
Yep.
I was wondering, have you thought about how you might quantify that?
Bayesian hierarchical models. No, I'm sure there are many other ways that we might think about quantifying, but you are spot on that test and evaluation is, I will add, it's about providing decision quality information that has appropriated caveated risks. And so there's always going to be a point that we don't have to reduce risk below, because we can't reduce risk completely. And so agree that, that's what this is about. And my point is that if we take all these sources of information and we collect them in some meaningful mathematical model, which my favorite personal one does happen to be Bayesian hierarchical models, that we can actually quantify that reduction in risk. And so we can say, if you've done this over here and we have these points of uncertainty, and then we go test this point and it confirms, or it adds another layer of information, all of that comes together in our evaluation assessment, as opposed to just the left hand side of the screen, or the left hand plus the middle, that we're taking all sources of information. And so I want to kind of wrap up with kind of moving to the future. And I know for those of you in the academic community, you might be thinking, well, we've already hit the end of this wave of machine learning and AI, or at least that's what I think. Unless we do the current wave of statistically enabled or statistical learning enabled artificial intelligence, we've started to kind of see the limitations all across the board. But that doesn't mean it's actually been translated into real systems solving real problems. That's the next frontier in my mind, because we haven't really gotten past pandas being puppy dogs and those types of things in a real sense. Yeah. And so to be able to do that, I think one of the core components is the T&E for AI, and this is also key to DOT&E strategic plan. What do we need to do to be ready for when AI algorithms get fielded? And actually, one of my arguments is, first of all, we already weren't ready because we don't know how to adequately test software with the exception of, piloted environments and, that have really rigorously wrung out the software. But here are kind of some of the themes, but also I'd say these are just, this is when I think about what good test and evaluation is, to quantify risk, to inform decision makers, to enable kind of rapid deployments of new capabilities. This is really just what good T&E is. It has nothing to do with AI per se. And so these are some of the things that I think you'll see throughout the work that we're doing. And then I'll highlight two specific areas that we're deep diving in. So first, has been present throughout this conference, the conversation around IP and data rights for AI-enabled systems. When we contract for these systems, do we require the vendor to tell us they're using a machine or a statistical learning AI algorithm in it? And if we do, and then we say, oh, but you're going to have all these extra test requirements. I'm not a lawyer, so don't, that doesn't seem like the right solution. But if we completely black box things, then we open ourselves up for risks that we didn't completely conceptualize before in conventional software. And so we're exploring what the kind of trade space is between white box and black box testing of AI-enabled systems. If we know exactly what the training data is, we know if it's a deep neural net, can we get away with less testing if we have all that information? If we can characterize the data to reflect an operational environment, what's the trade space there? And then my picture on the right hand is kind of the new methods and metrics for testing AI-enabled systems, and really calling out some different components of things that we already did. So from an operational testing perspective, they really focus operational effectiveness, suitability, and survivability. I'm flagging kind of two elements that really need special attention when we're talking about AI-enabled systems. And so the first one is measures of the AI, the algorithm-based agents themselves. And so that's the performance of the algorithm, but also the training data sufficiency, because when we're talking about the current wave of machine learning and AI, it's just learning on the data. And so if we don't know what that data is, and we have no way of quantifying what that data is to a decision maker, I don't know how they make that decision. If they trained only on data in Afghanistan, and we are now fielding the capability in Ukraine, not that that's happening, but current operations, is it still going to work? How do I know what I need to do to go retrain? What are my risks there? If we don't know those things, then we don't know what the performance of our system is. So that's a really foot stomping one for me, is that if we're going to field AI enabled systems, we really need to understand how they were trained, just like we like to understand how our humans were trained. And then something that really falls under operational suitability overall is we've always had kind of a human factors, a usability kind of human element to that assessment. But now we're talking about human agent teams, and really starting to think about what is the feedback loop between our algorithms and the humans. What is the cooperation, collaboration? How do we improve that collaboration once we have AI enabled algorithms? And so these are some areas, I didn't make them up, they are from the team-based literature that has existed for years on kind of the human side. And so thinking about new metrics that capture the human to the agent piece is important. And then the last piece that I'll flag is that while all of what I said before, I think are kind of the building blocks for how we get to this really big picture conceptual vision, we're not ignoring the big picture, because DOT&E won't let us. And we shouldn't ignore the big picture. So we are going to be doing some workshopping. So this is where the research plan is a little bit more sticky or squishy. But we're going to be looking at, how do we get ready for T&E in this complex, evolving, interoperable, networked system environment? And so we're going to be hosting workshops with our government partners, and all of you are invited as well as we move forward to talk about, what is actually needed, where are the challenge points, can we start to develop some scenario-based simulations, what's a sample kind of model kill web, for those of you that are following kind of the mission engineering language, and then how do we experiment in that dynamic to kind of inform what is needed from a joint test concept for DOT&E to write policy on how we get there going forward. And so with that, I will say that this is, my picture, or VT was on the front slide, but that's because I couldn't figure out how to put all these graphics in the front slides. That there are many of you in this room, as well as several of you, those who are not, are all collaborating on this project. So it really is a large multi-institution collaboration to help solve these problems. And my big picture summary is our systems are changing. Systems engineering and test and evaluation are changing or need to be changing. And digital transformation provides us an opportunity to really bring these disciplines closer together. And so it's a real complex space that we have to operate in to solve these. And so my Venn diagram, or my flower of expertise, I don't know, is over there on kind of how our team is structured. And we couldn't do it without any part of this team. And we probably need other elements to the team that we just haven't thought of yet, and we'll be bringing on as we hit roadblocks and say, we don't know how to answer this. And so, you know, this interdisciplinary nature is really going to be necessary to solve how do we bring all of this information together to better inform decisions in the department. And I will stop there because we have to run across the hall. Sorry, I talked too much. Yeah, Dan.
Ideas for, so, as you know.